Institute. Today I will share this paper, Plastic Pirates Sample Litter at Rivers in Germany. So I will start. Okay, I will start from the abstract. So rivers are an important source of marine anthropogenic litter, but the particular origins of riverine litter itself have not been well established. Here we use a citizen science approach where school children examined litter at Riverside and identified possible sources at over 250 sampling spots along large and small rivers in Germany during autumn 2016 and spring 2017. Litter densities have an overall median of 0.14. Interquartile range 0 to 0.57 items per square meter, and an overall average standard deviation of 0.54 plus minus 1.2 liter items per square meter. Litter quantities differed only liter by sampling year. The principal litter types found were plastics and cigarette butts, 31% and 20% respectively, followed by glass, paper, and metal items, indicating recreational visitors as the principal litter source. At many sites, 85% accumulation of litter consisting principally of cigarettes and food packaging have been found. At almost all sampling sites, 89% litter potentially hazardous to human health has been observed, including broken glass, sharp metal objects, used personal hygiene articles, and items containing chemicals. In the search for litter source, the school children identified mainly people who use the rivers as recreational areas, in contrast to residents living in the vicinity. Illegal dumping or the river itself depositing litter from upstream source. These results indicate the urgent need for better education and policy measures in order to protect riparian environments and reduce input of riverine litter to the marine environment. So this paper, the scientists use citizen science, mainly school children, to do the survey at almost the main river system in Germany, and the sampling time is at 2016, the autumn and the spring of 2017. So here I will and the main question of this paper is to the first is to identify the main litter type at riverine areas, and the second is to test the source of this litter, and the third is they want to define if there is any dangerous items at among these riverine litters. So here I will go through the figures and tables first. So here is the river system of Germany. So you can see they are four main river systems: the Elbe, Weser, Rhine, and Danube. So these three, Elbe, Weser, and Rhine, it goes to the North Sea, and there are also some small rivers. You can see these purple spots. They go to Baltic Sea. And about the Danube, here is the Black Forest of Germany, and here is the origin of Danube. So Danube here, it will go along Europe and goes to Black Sea. So they are different river systems. And here I list the total length of rivers here, but actually the Danube only the upper part, the beginning part of Danube, so not this long, but they are quite big. So this is the areas they spot, and at this figure you can see the green spots are the most. So because they didn't request, they let the school children to freely choose where they want to do the survey, and there is no compulsory survey. How to say? The school children can depend on their capacity, their people number, and the time they can contribute to decide how they will get involved in this survey. So you can see the Rhine River has much more survey spots than other rivers here. So this is figure 1, and figure 2 explains how they do the surveys at Riverside. So we see, let's see figure 2A first. So here is the Riverside, and they divided the river bank to 0 to 5 meters, 5 to 15 meters, and 15 and above 15 meters. So they are Zone A, Zone B, and Zone C. So at each zone, they will use sticks or stones to make a circle, and the radius of the circle is 1.5 meters. So they will survey 9 points at one area, one sampling stations, and so at the sampling spots, they will see the accumulation of liters. So here they define accumulation as the liters gathered less than 50 centimeters. So here you can see there are some small cigarette accumulation here, but this cigarette accumulation and this big circle, they are about larger than 50 centimeters. They are 2 accumulation, and at this big gray circle, the green liters, they gather less than 50 centimeters. So here they count as 1 accumulation, but they are medium size. This is how they do the survey. And here they so when the school children survey at the riverbank, they can take photo to record a liter type with the whiteboard as reference. So here you can see some photos here. So four is here. I go to figure 4. Figure 4, the procedure they explain what kind of data will the census assist or project. I will not go one by one, but you can see here is a really, it's a quite long procedure. In the discussion, they mentioned that because they a serious attitude towards this data. So if the data is not complete or has some gap, will reject it. So here they show how they decide the data accepted or rejected. Okay, so at page 7, here is table 1. At table 1, you can see the river system, the 2-year they surveyed, and of each river. And the first is if they encounter litter at the river bank, and about 90% at all rivers and 2017 they have litters at the bank, and they are 61%. Also, the percentage is high that the sampling circle has litter in it, and the litter density is here. And about the accumulation part, the Danube has the most litter accumulation, and Rhine is the second. But you can see the number there is no big difference. Actually, the percentage is quite close, and this column is the average number of litter accumulation. So here, the Danube has the most number of litter accumulation. Yes, and the rivers that goes to Baltic Sea, the small rivers, the accumulation is the least. And the last is if the school children find any dangerous materials at riverbank, and you can see the percentage is also high. Almost they have a high percentage number to encounter dangerous materials. So here is table 1, and let's go to table 2. So in table 2, they use the AI. They use AIC to test which model performs best, and so they use different variables to test, and the river system and times year have the smallest AIC number, so this one has the best performance to explain the data. And the figure 5, let's see the A of figure 5. So figure 5A explains will they encounter the percentage of sampling circles with litter, and you can see the green box I make. The river system goes to North Sea. The Rhine, Weser, Alp, and other small rivers goes to North Sea. The patterns are similar, and this river system is different from the rivers. The small rivers goes to Baltic and Danube. Danube goes to Black Sea. So you can see the river system are quite different. Below the B, this figure is, let me see the figure is a box plot. So the box plot figure is a convenient way of visually displaying the data distribution through their quartiles. So here, at this box plot, you can see the key value, like the maximum and minimum of the data distribution, the median and the quartiles. And you can, through the box plot, you can see if the data is symmetrical. and if there is any outliers, and how tightly is the data grouped. So through these box buckets, you can see if the data is how the data is distributed. So at this box plot figure, we can see the rivers goes to Baltic Sea. The river system goes to Baltic Sea, has the low density of litter items, and these rivers, the North Sea river system, they are the pattern, the data is similar. Yes. Okay, and the numbers here means the outliers of the data set. Okay, and the figure 6. The figure 6 is the composition of Riverside River. So here I make the average. So you can see the plastic is the largest amount of liter category, and the second one is cigarette butts, and then glass, paper, and metal. But they are quite different. So at the Baltic Sea, the glass is less than these three other river. It's different from the river system goes to North Sea, but it's close to the Danube, and there is also some difference between the 2-year sampling. But through this figure, we can see the plastic still the plastic and the cigarette butts occupies about 50% of the litter composition. Okay. So on figure 7, for figure 7, A is the dangerous items they found at the riverside, and B is the source. So at you can see the both year of 2016 and 2017, the percentage of finding dangerous material is quite high. It's more than 80%, and the top one is broken glass, then other like sharp metals or used personal hygiene articles and other stuff. So this is 7A. And about the 7B, they want to know, so what's the main source of this litter? Where do they come from? And they are quite surprised that the visitors accounts for 87% of the source, and the residents is less than 40%, and the river depositing litter is 31%. Before they do the research, they reviewed other literature, and some literature indicates that they are more litter because of comes from the residents or comes from illegal dumping. But here you can see the visitors. In Germany, visitors accounts for the main source of litter, and the second is residents and river depositing litter. Illegal dumping or other like shipping or industry actually is not that many. So here is the figure 7 about the dangerous materials and source of the litter. I think that's it. Oh, table 3. I think table 3 is the last table. So at table 3, they use a test to see the dangerous materials and litter source, and you can see the p-value. So on the dangerous materials, the broken glass is the sorry, this table I didn't understand clearly. Okay. Okay, so let's back to the material and method. Okay, so back to the introduction. So this paper is the main objective of this paper is to, the first is to estimate the quantity of litter at rivers of various size and identify the material composition of litter. The second is evaluate whether larger accumulations of litter or objects potentially hazardous to human health are present at Riverside. And the third, determine the source of litter. The materials they use a citizen science project named Plastic Pirates. So here I can share you the project. Here is the Plastic Pirates website. So they have English and Germany at this website, and there are a lot of materials like flyers and even books for children. So this project is still going on. So they use this project to call the high school students to join the challenge. And so in total, there are more than 5,500 students come over 340 different schools and organizations. So there are really many school children engaged in this project. Okay, I continue. So the river content on the river system. So here is a beautiful piano music. Comes from where?
From your side.
Okay. Okay. So the river system, actually the sampling sites were grouped according to river system. That means the main river and where the river finally flow into. So almost all major river systems and small rivers in Germany has been investigated. And I just mentioned on the map, so the Rhine River is sampled most frequently and followed by other big rivers like Elbe, Weser, and Danube. So about half of the river went to the river less than 20 meters wide. So that's their sampling site. And the sampling method, I just explained at the figure below. So they use at each spot the transect. They divided 3 transects, and each transect they make a circle, and they sampled all litters within the circle and classified according to the litter type here. And so they ask the school children to use a measuring tape at the riverside and coordinate the corner points with a GPS device or smartphone. But later they also found because maybe the school children cannot operate correctly, or there is some personal misunderstanding. So about the smartphone, they didn't perform well, and therefore they object many data because of this error. So the accumulation, this is the definition of accumulation, and I also explained at the figure. So I will skip here. And here is the inference of litter source. So they list the potential source of local litter pollution, including residents, visitors. Visitors means people using the river environment as a recreational areas, and people dumping litter illegally, industry, shipboat traffic, and the rivers itself, because the river may wash litter from upper source. And so here they explained how they group the answer and later into the test. So here here is the verification of the submitted data, and I will skip this. We just done that. So on the statistical analysis, so at each sampling circle was treated as one data point. So that one group, one sampling station, there are 9 data points, and they test the variables of river system, sampling year, riverside zone, and any interaction stuff. So here they explained how they do the test, and they use different models, and they also use different test methods to understand the litter densities at river of different size, and the litter accumulations, dangerous materials, and the source and litter source here. So here is the statistic and analysis. So I will go to the results. So as I mentioned earlier, the majority of group, 90%, identify at least 1 litter items at their sampling site, and 2/3 of all sampling circles contain litter. You can see table 1. And the best fitting model considered the river system and sampling year, the model with the smallest AIC number, the significant to predict encountered litter densities, the percentage of sampling circles with litter, as well as the count of litter items differed significantly between river system and sampling year. But the pattern was inconsistent. So in some river system, the density was higher in 2016, but in others, it may not, it's different. And the model also show a significant difference in litter quantities per sampling year, yet the difference is very small. Litter densities at the riverside further differed according to the size of the river. And small rivers up to 10 meters wide had significantly less litter than wider river. So here it's about the river goes to Baltic Sea. Most of them are smaller. Riverside litter consists mainly of plastic, followed by cigarette butts, glass, paper, and metal. And there are also food leftover and other items where they are smaller. Litter composition differed between river systems, years, and rivers of different size, but the differences were often relatively small and not consistent. So here's table 1. On litter accumulation, the occurrence of small accumulation and medium-sized or even large litter accumulation have been seen less frequently, so most are the small accumulations. And the average of litter accumulation is 1.5 plus minus 2 accumulation per 1,000 square meter. So most litter accumulation was spotted at Riverside at Danube River system, followed by Rhine. Less accumulation were found at rivers flowing into the Baltic Sea, and there are no significant difference between river systems considering the total amount of river accumulation or size classes of litter accumulation. So they also asked the school children to take photos, and there are several people to test to verify the photograph. So on the photographs, they found the type is food packaging, smoking, preparing and consuming food, and consumption of alcohol. So food packaging are the most here. On dangerous materials, nearly all groups observe at least one dangerous litter items of any category at their sampling site. The type of dangerous materials found differed significantly. Broken glass was found significantly more often than sharp metal objects and used personal hygiene articles. So there was little and non-significant variation between river system and sampling years in the percentage of sampling sites where dangerous materials is present. So in their survey, they found at nearly all groups, all river systems, and both years they found dangerous stuff at the riverside. On the inference of litter source, so groups at almost all sampling sites considered visitors who use the river as a leisure area are a likely source for local air pollution. This was significantly more often than the consideration of residents and the river itself. So they explained that the visitors have been identified in all river systems and both years as the most likely source of litter, but the order of the source varied slightly. Size of the river did not affect the frequency of mentioned source, with the exception of the shipboat traffic being mentioned more frequently as the likely source of litter for rivers wider than 100 meters. So the photo also suggests the majority of accumulation could be attributed to visitors. Here is the last part of a discussion. So they recognize that there might be some limitation using citizen science as approach, but the scientist can use other strategies like training or instruction or data verification mechanisms to increase the quality of data. And with these strategies and methods, you can increase the quality of data, and the data done by volunteer can be able to match as the professional scientist. So they use different methods, and they find the most groups and participants were able to correctly identify, quantify, and classify the litter encountered at the riverside. For the inference of litter source, the photos of litter accumulation will help to verify the most litter originated from visitors. And here is the litter quantities at river in Germany. So the quantities of riverside litter differed between river systems. The more polluted riversides were located along the Rhine and Danube system, following through Germany's most and second most population region respectively. And the Germany, per capita waste production is over 2 kilograms per inhabitant per day in Germany. So they show that there is a link of population density and the amount of mismanaged plastic waste into the sea. And they also find that larger rivers wider than 10 meters are also showed higher litter densities than small streams. So large rivers are also likely to attract more recreational visitors. The survey was taken in 2 different seasons, but they cannot find a difference between these 2 seasons, and they don't know what the litter quantity performs at other seasons. So they suggest maybe in the future they can also test these variables. So about the litter accumulation and dangerous materials, there is no difference between river system and the sampling year. So they want to illustrate that the dangerous materials they found at the river's bank, the riverside, is not only dangerous to wildlife, but also to humans. And they here they said about 2/3 of the litter encountered at the riverside has buoyant properties, like the plastic. They can floating all the time. So here they said maybe there's a the government can have necessary measures to collect these buoyant litters before they go to the sea. And here is the they discuss about the source of riverine litter pollution and litter mitigation strategies. So so they mentioned that different reference of doing the riverine litter survey in different countries, and they in this literature they identify illegal dumping as the main source of litter, but here in Germany they find the most likely the litter source comes from visitors. So here they also find other literature support these findings that visitors act as the main source of riverine litter. So about the mitigation measures, they think the picking up litter in the presence of visitors can also be shown to reduce litter quantities. And they suggest a government strategy to reduce the production of single-use plastic products is helpful to decrease the litter at the riverine. And that's their suggestion. So in conclusion and outlook, so they think that using citizen science approach is a useful tool to gather data, and because the riverine litter research is relatively less than marine debris research, so they suggest there is more can do in the future. So here is my sharing. Do you have any question?
Thank you very much, Yanning, for your explanation in detail. Now it's time for discussion among participants. Any questions and comments? Jolene? Any others?
In particular, about sources, how they connect sources to the item leader, especially for example, especially for items from visitors versus items from illegal dumping.
Yeah, it would be very difficult to identify the source of the litter, but from this paper, you can say that it's from the intrinsic decision of the participants. Yeah, children. They look around the situation of survey transact and the composition of litter. They can decide what kind of sources may be potential sources of litter in the area. They responded with a question, like a 5-point Likert scale with the data card.
Then they described in the manual how they decide. For example, household items like electronics and big items.
Mm-hmm.
In Korea, we usually think is from illegal dumping, like tires or refrigerators and washers.
Mm-hmm.
But the small item, we don't think is from illegal dumping. So it should be included in the manual, how they decide this is from illegal dumping or from visitors.
Yeah.
And I was surprised at these dangerous items. In my opinion, in Korea, we don't find many broken glasses like this. In figure 3A, they showed us a lot of broken glasses. But I think in Korea we don't see a lot of broken glasses. It's because of the separation of household trash. We separate glasses and other things. We recycle. So, and another opinion, in Germany, people go to rivers for recreational purpose.
Yeah.
We don't go to the river.
We go. Yeah, and we can find many leftover debris in Riverside, especially just beneath the bridge.
Just beneath the bridge.
My assumption is Germany people take a lot of beer to drink at Riverside.
Maybe.
You can drink.
That's my assumption.
Always the Yongsan side, right? We don't see churches like this and Nakdong River.
not that many,
Yeah,
not frequently.
so it's I mean it's different from country by country.
Yeah.
Any other questions?
And
About the method that Jung-Soo mentioned, I think they make a detailed description at their supplementary materials, but unfortunately I cannot download those supplementary materials, so I don't know how they define or teach those school children to identify the source. I'm also curious about it. Yeah.
I can send you the supplementary material.
Okay. Thank you.
When we conducted research for developing Korea's national marine environmental education plan, I found this project as a representative marine environmental education program of Germany. But finally, I found the result in the research paper. It is very shocking, and I think they produce very useful results. And I just find out that this study was supervised or advised by Martin Thiel, who is the leader in marine citizen science field. So this study was comparatively well designed research and education project.
Yes.
one more comment for figure 6, we can see plastic percentage for all legal. Compared to the ocean data, percentage of plastic is smaller than several weeks ago I presented a paper, but I don't remember where, but in that paper too, plastic percentage was smaller than oceans. And previously I mentioned about the figure 3. It may be because of the little amount. In Korea, we generate 1.04 kilometers per day, half of German's generation of waste. Daily generation of waste. So they can find many traces in the river. We generate half of waste generation. This 21, we have 1.04.
My comments on this paper is one selection of alcohols in each time should be random. I think children could choose alcohols in each transfer would biased more items existed. This is my comment. And the second concept of accumulation here. I'm not sure why they define the accumulation, which is 50 centimeters distance between items. That is the arbitrary definition
I thought of this accumulation description. If the leader accumulates in one area, we can think it's dumped to another. Not waves or winds. It's not connected.
Some possibility of that.
The wind or other natural They may be scattered. People and they accumulated in one spot.
That is a very tricky question. So we should differentiate illegal dumping and littering. Littering is like a kind of lefting over of some
Here.
debris items, but illegal dumping is intentional dumping for like big or not too easy treatable waste items from the household or from the companies. So there are some tricky situation in categorization of dumping and littering.
One more comment. Circular area is better than rectangular area?
Yeah, I'm not sure, but it's a good idea.
Yeah.
I have some more comments. One is about the citizen science. They provide detailed manuals and figures to explain the method. They don't have any other training courses or educational opportunities. They just provide some basic materials and information, and then they check the result, and then they rejected a lot of percentage of the data. So that is another way of citizen science to apply in this study. And one more thing I would like to say is, when I think about if we can apply this method to Korean situation, we have safety issue. We have some experience to survey riverbank, riverside areas according to CSIRO methodology, and we found some dangerous situation to assess approach the riverside, and we have a lot of artificial areas along the river. So it's probably in many cases it's not applicable to Korean situation. That's it. Any more questions and comments? More?
I can share why we choose this paper, because this year we cooperate with Taiwan's NGO SOW, where Jason worked before, and we designed a survey method to survey Tamsui River, the biggest river in Taipei City, about more than 200 kilometers. Yeah, but unlike this approach at this paper, we trained the volunteers in advance, and we designed the survey areas like every 500 meters. Every 500 meters there is a spot. So we designed a protocol for them to survey. So, and they surveyed by riding bicycle. So it's a bit different, but our approach is also want to learn the population, the pollution levels at the riverside.
Thank you very much for sharing.
Thank you.
It's time to wrap it up.
Okay.
And we I'm sorry to some inconvenience to connect. Then our next seminar will be
7th of April.
Yeah, I'll choose the paper.
Jongsu will choose one paper and share with you guys. I'll see you next month. Thank you for joining again.
It's 7th of April.
7th of April.
Okay. Bye-bye.
Bye-bye.
Bye.
Bye. Bye-bye.
Bye-bye, Lorraine.
녹화를
저거